Okay, in previous lesson we have looked into the simple interest. Okay, so now we are going to continue with compound interest. Compound interest. Okay, just now I've mentioned about the simple interest. Simple interest is only involved the principal and the loan term. Okay, so it's only involved the principal and the loan term. Okay, the interest which is charged is only based on these two. Whereas when come to compound interest, it's going to be charged on the interest, on top of the interest. For example, you have the loan for 1 year. Let's say taking it for 1 year. So the first amount, the first interest is charged during the first month. So the interest charged will be deposited to your account, and then for the second month, the interest will be charged on the balance on the first month. Which means, let's say the first month you have the principal together with the amount which is accumulated on the first month as the interest. So the second month interest will be charged on the first month. Okay, for example, let's say I have 10,000. I borrowed bank 10,000. Okay, the first month I never pay to them. So what they do, they will charge me interest. Let's say my interest is $25. Okay, when they go for the second month, the interest going to be charged is going to be based on this amount. For the first month, they only charge my interest on this particular value. But when I go to the second month, since I never do any payment during my first month, so when I go to the second month, the interest that going to calculate it is going to be based on this principal. Okay, and to find the total total amount that we're going to pay, okay, the total amount that we're going to pay is going to be P 1 minus R over 100 power of n. Okay, sorry, 1 plus. Okay, so total amount is P multiplied by, the P is a principal, 1 plus R over 100 power of n. Okay, okay, so here one example I gave you. Find the amount in the account and the interest earned. So they want the total amount and the interest earned. After $5 is invested for 4 years at 6.5% per annum, interest compounded annually. And this is very important. Okay, so this compounding period is very important. Okay, please take note. So since here they say compounded annually, so we can use this particular value, the interest, as it is, because it is interest per annum. So for 1 year they charge this particular rate. So here is compounded annually, so we just use this value. So the total amount in the account is going to be A equivalent to P 1 plus R over 100 power of n, which is equivalent to 5,000 1 plus 6.5 over 100, and the n here, since it per annum and they compound annually, so the n here is going to be in years, 4 years. Therefore, the total amount inside the account is going to be so since it is a monetary value, so it's going to be $64.32.33. So this is total amount that accumulated in the account. So this total amount is included So total amount is included principal plus the interest earned. Therefore, the interest earned is equivalent to the total amount in the account minus the principal, which is going to be 6432.33 minus 5000, which is equivalent to 1432.33. So this will be the total interest that we earned on this investment. Okay. Okay, now let's look into another example. Find the principal that we will grow to the 4000 in 6 years if the interest at quarterly at 6.5 per annum. Okay, if you notice here, the compounding period is now different, it's quarterly. Means in 1 year, we are going to add the principal 4 times, quarterly. Okay, sorry, the interest going to add is 4 times in a year because it compounded quarterly. Okay, so first, let's look into the formula. A equivalent to P 1 minus R over 100 power of n. This is the formula. So now, here the R value and the n value we're going to redefine or recalculate. Okay, so the R here they gave you 6.5 per annum. For 1 year is 6.5. So if they compounded quarterly, okay, it's going to be 6.5 your R value divided with 4. So means each time they compounded, what is the interest rate? So it's going to be 1.625. And then your n value, here they gave you 6 years. But the payment that you're going to receive is 4 times in 1 year. Therefore, your n value is going to be 6 times 4. Therefore, we will calculate. So they said this is the total amount that grown. So it's going to be A, which is 4000, equal to principal value, we don't know yet. That's what we need to calculate. 1 minus my R is going to be this particular value, 1.625 over 100. 1 plus, sorry. And n is 24. Okay, therefore your principal value is going to be 1.625 divided by 100 plus 1 power of 24. 4,000. So your principal is going to be 4,000 divided by this is 2716.73. So this will be your principal value that you have deposited to the account. Okay, let's look into another example. So here, find the interest rate. So here I ask you to find the interest rate per annum that will be enable an investment of $3,000 to grow to $4,000 over 2 years if the interest is compounded quarterly. So here I have a different compounding period, which is a quarterly. Means in 1 year I am going to have 4 terms of payment, okay, of the interest. So means in 1 year I am going to have 4 times they need to pay me the interest. So now going to the formula. So A equivalent to P 1 plus R over n. So the A is 4,000. P is 3,000. 1 plus R we don't know. N is 2 years, so quarterly, so it's going to be 8. Okay, there are 8 quarters in 2 years. So it's going to be 4 over 3 equivalent to 1 plus r over 8, so it's going to be minus 1 equivalent to r over 100. Okay, so 4 over 3 of 1 over 8 minus 1. So here I get 0.03661 equal to r over 100. Therefore, r equal to 100. So it will be 3.66 equal to r. Okay, but this r is going to be r over 4 equal to 3.66. Okay, therefore r value (14.46% per annum). Okay, so with this we stop our compound interest lesson and we'll continue with next video. Thank you.